Good afternoon, students. Actually, I am having some work during this 2 to 3, so I will be taking your class right now. I have already circulated the message on the WhatsApp. We have yesterday completed the one of the aspect of the normal distribution, and that was that when the normality is deviated, then how we can judge that. So for that we have studied certain parameters. We have studied about the movements, then we have studied about the skewness, and then we have studied about the cut. Okay. So now we are slowly and slowly, when we have started from the probability, then move on to probability distribution, and then we have studied this movements, skewness, and kurtosis. Now we will be moving one more step ahead towards this inferential statistics. And one of the important thing that we do in inferential statistics is we take out the sample from the population, because this thing we are telling you right from the first lecture, that it becomes very cumbersome or almost sometimes impossible to study a population. Okay, because of the number of individuals in that. So that is why in statistics a sample is drawn from the population, then our statistics and the data collection is applied to that sample. And finally, whatever the results are obtained, those are assumed to be the representation of that population. So it becomes very essential that whatever sample you take out from the population, it should be a true representative of that. Okay. And when a sample needs to be a true representative of a population, then there should be some methodology, or there should be some procedure behind that, so that we can ascertain that whenever we are choosing a sample, it will be a true representation of our. So that is what we are going to study today in this lecture. That is what is this sampling methods, and how this sampling is done, and how we can obtain a good representative sample of a population. Okay, so let us start that thing. So sampling has been an age-old practice in everyday life. It is not a new thing. It has been done since time immemorial. Then whenever we want to buy a huge quantity of commodity, you might have seen that when we are going to buy something or some quantity of commodity, then we decide about the total lot by simply examining a small fraction of it. Even you go into the vegetable market, you pick up some of the vegetables, then you see them, and then you ascertain, okay, that whatever the quantity I will be taking, that will be the representative of this particular set. Okay, so it has been established that sample survey, if planned properly, can give precise information. Since in surveys, a part of the population is only surveyed and inference is drawn about the whole population, the results are likely to be different from the population values. So it must be noted here that when we are doing the statistics on sample, it is not necessary that we will get the exact population values. Okay, so but those value will be near to those population values. So that is there. So that is why we choose to take the samples. Okay. So basically, but the advantage with the sample survey is that the type of error can be measured and controlled, and it can be eliminated to great extent by employing properly trained persons in the survey. Survey we have already studied that how many types of survey in the methods of data collection. The other advantage of sample survey is that it is less time consuming. Okay? But it is less time consuming, and it involves less cost. So that is why sample survey are preferred. Usually the population is too large for the researcher to attempt to survey all of its members, and that is why a small but carefully chosen sample can be used to represent the. Okay? The sample reflects the characteristic of the population from which it is drawn. Okay, so now we will try to understand the meaning of sampling. What is the meaning of sampling? So statistician use the word population to refer not only to people. Here you should understand this thing. Okay, this particular meaning given by Lavin and Rubin tells you a lot, because we are many a times we are confused about it. Okay, so what it tells is statistician use the word population to refer not only to people, okay, but to all items that have been chosen for study. That is, if I am talking about a study of Murrah buffalo at LRC farm, then I am confined to the Murrah buffaloes of LRC farm only. It is not like that whole of the population of the Murrah buffalo has to be considered. Now the buffaloes of the LRC farm will be considered as the population. Okay, so they use the word sample to describe a portion chosen from the population. Say for example, we have 100 buffaloes at LRC farm. So that 100 buffaloes constitute a population. Out of that, we are studying 20. So that 20 buffaloes will be our sample. And those 20 buffaloes should be theoretically a good representation of the population so as to get the good inferential results. Okay. So a sample, it is given by Crouch and Hodgson. A sample is a limited number taken from large group for testing and analysis, on the assumption that the sample can be taken as representative for the whole. Okay. Then what Boyce said, that sampling makes an estimate about some of the characteristics of the population. To sample is to make a judgment or a decision about something after experiencing just part of it. So these are some of the meaning being defined by some of the scientists and statisticians about the sampling. Okay. Now we will try to understand the concept of sampling. Okay. So for clarity and brevity, some concepts and preliminary of sampling theory which are used in the study material are discussed below. Okay. Now we will be studying them one by one. So what is sampling units versus population or and populations? Okay, so a unit may be taken as a well defined and identifiable element or a group of elements on which observations can be made. What is a sampling unit is? Okay, it can be a well defined and identifiable element, either one or a group of elements on which you are going to make the observations. Okay, so that constitute your sampling unit and aggregate of these units, because in a population there will be several units, such units which can be taken out from the population. So if we aggregate all those sampling units, so is termed as population. And population is said to be finite if the units are countable. If you are able to count all the units in a population, then you have to call that population as a finite population, because you are able to count them. So the population is subdivided into suitable small units known as sampling. Okay. So what we do generally is that in a population, we divide them into suitable small units, and those small units are known as sampling units for the purpose of sampling. Sampling units may consist of one or more elementary units, and each elementary unit belongs to one and only one sampling unit. It is not like that in a sample, say for example, in a population, you take out one sample, then second sample. So the every unit in a sample is mutually exclusive. That is, either it will reside in this sample or this sample. Means the sampling units do not overlap with each other. Okay, so they do not overlap with each other in terms of units contained within them. Okay, now what is a sampling frame? A sampling frame is a list of sampling units with identification particulars indicating the location of the sampling unit. Okay, So sampling frame represents the population under investigation, and it is the base of drawing a sample. As far as possible, it should be up to date and free from omissions and duplications. We will be discussing this with more detail at the last. Okay, but sampling frame actually represents your population under investigation, and from this sampling frame only you have to draw the sample. Okay, in which each sampling unit have a particular identification and the location. Okay, so that you can identify them and locate them, so that you can pick them out when a sample is being selected. Okay? Now, what is a sample? A fraction of the population is said to constitute a sample. It is nothing but a fraction of the population. And the number of units included in the sample is known as the size of the sample. Okay. So, what is a sample? Sample is a fraction of the population that is said to constitute a sample. Okay. Now, what is sampling fraction? Okay. So, the ratio of the sample size n to the population size capital N is known as sampling fraction, and it is denoted by n divided by capital. So, if you are choosing, say for example, out of 100 buffaloes, you are choosing 20 buffaloes. So, your small n will be 20 and your capital N will be 100. So, your sampling fraction will be 20 by 100, that is 1 by 5. Okay. What is sampling procedure or method? This is the method of selecting a sample from the population. That is how you are going to select a sample from a population. That is known as sampling methods. Okay. Now, what is census? So, this denotes all the elements or the unit of a population. That is, if we are talking about the census, livestock census, then you cannot leave any of the member of a particular identifiable characteristic. That is, say for example, if it in a census it is said Murrah buffaloes, then Murrah buffaloes anywhere in India. Okay, if they are being there, they are counted, and then the population of the Murrah buffalo is being given. Okay, which are used to explain the features of a population. So it usually refers to the complete enumeration of all persons in the population. So complete enumeration of all the persons in a population constitutes a census. Now, population parameter and sample estimator. What is a population parameter and what is a sample estimator? So, any fraction of the values of unit in the population, such as population mean or population variance, is termed as population parameter. Okay, if you calculate the population mean or their variance, it is known as population parameter. Okay, there can only be one set of values of the population, and the population values are treated as constant. Say for example, we have a Murrah buffalo. We have a population or the census for that. So whatever the mean value or variance you will be getting, that will be constant. That will only be one, because a population is only one. Okay, that census population. Take whole of the population. However, the function of the values of the unit in the sample, such as sample mean. Now, we say for example, now I am having 100 buffaloes. I am considering it as a population. So, if you will be taking the mean milk yield of those buffaloes, so it will be constant. It will always come same. If you take the variance, it will always come same, because that population is constant and the individual resides in it are also constant. Now, I am going to take a sample of 20 buffaloes. So, when I will be choosing 20 buffaloes, it may be possible that next time when I will be choosing, the individual will be different. Because individuals will be different from one sample to other sample within a population, so their sample mean or the sample variance are known as statistic. Okay, they are not known as parameters, they are known as statistic, and these statistics vary from one to another. It depends on the sample. That is, the value of mean and variance differ from sample to sample, and therefore it is a random variable. This question many a times being asked, that parameter is a constant, whereas a statistic is a random variable. This statistic is a random variable because it depends on the chance that which individuals are being selected in the sample. Now I think it is clear to you. Now what are the advantages of sampling? Okay, we have already studied one two things. So it costs less, takes less time, data are acquired quickly, fewer mistakes are likely, and a more detailed study can be done on that. Okay, which are not being most of the time possible in case of population. Okay, now we will be studying types of sampling. What are the different types of sampling? There are broadly two types of sampling. One is the probability sampling, okay, and other is a not sun, it is non-probability. Okay, it is non-probability sampling. So the probability sampling is a probability sample is one in which each probability sampling, then it can be systematic sampling, okay, and it can be stratified sampling, right? So now we will be studying in probability sampling. Say for example, there are 100 buffaloes and we are going to choose 20. So every buffalo has the equal chances of being selected. Okay. So these probability methods are further divided into simple random sampling, systematic sampling, and stratified sampling. So now we will be studying about these three types. That is, what is a simple random sampling. So the random sample contains that each and every individual in a population has an equal chance of being included in the sample, and that the selection of one individual is in no way dependent on the selection of the another. Means they are mutually exclusive. We have studied in the probability, na? That is, here the P A intersection B will be equal to 0. Okay, because the occurrence of the A is not dependent on the occurrence of the B. So in simple random sampling, each individual is having equal chances, and the probability of selection of one individual is no way dependent on the selection of the another person. So the two popularly used method of random sampling are lottery method. One is the lottery method and other is the random number table. Okay. However, nowadays these random numbers are also being generated by these computers. Okay. Say for example, one of the example I will give you. I am sending you passports for your attendance. Okay. So those passcodes for attendance are also being generated through computer. Okay, and those are unique every time, and that pertains to each individual. Okay, so here in simple random sampling, there are two methods of simple random sampling. One is draw of the lottery, and other is the using a random number table. Okay, so now, draw of a lottery. We will just try to understand that how we can select the individual using simple random sampling using the draw or a lottery method. Okay. So in the lottery draw, for example, if we have to select sample of 25 students from a total of 600 students in a college, then what we will do? We will simply make separate slip of paper for 600 students, put them in a box, thoroughly mix them, and after that a person is asked to pick up one slip. Here the probability of each student being selected in the sample is 1 by 600, and this procedure is continued till the sample size is acquired. Now, some students may think of that, say for example, when we have selected first individual, we have a probability of 1 by 600. But when the next individual will be selected, it will be having the probability of 1 by 599. So how the probability remained the same? But the fact here is, when this individual is being selected, all individuals were having 1 by 600 probability. But next time, every individual was having a probability of 1 by 599. So the available individuals each was having equal opportunity to get selected. So that is why in each draw, every individual was having equal probabilities. So that is why this is called as the simple random sampling, as the definition, that every individual in each draw was having equal. Now, how to do this thing with the random number table? Okay, so I think actually I have not added it. What I will do, that I will add this random number table after uh, this lecture. Okay, so actually this has been given according to that random number table. So we will you can very well be easily able to understand that how a random number table can be used to select the individuals. Okay, but for that I have to attach that appendix, that I will do before giving you the final this lecture notes. Okay, so we will just take up this thing. Okay, you can study of your own, everything is in detail. So the only thing is, because right now appendix is not there, so I will be adding it up, and you will be able to. So next thing is systematic random sample. Okay. So what is a systematic random sample? So what we do in systematic random sample, that designing a systematic random sample is sometimes quite difficult and time consuming, and therefore simple random sample like simple random sampling, systematic random sample like simple random sample, also uses a list of all the members in the population. Say for example, in the earlier example, 600 students were there. We have to mark for each student. Okay, then only we can do this. So, however, instead of using random numbers to select the sample elements, the researcher applies a skip interval. What happens in systematic random sampling? That is, they apply the skip interval to the list to produce a sample of required time. And how this skip interval is calculated? Skip interval, this k, is equal to number of elements in the population, for example n, and required sample size is small n. So this will give you the skip interval. For example, if we have to select 100 persons from a universe of 1000 population, then the skip is 10. In this case, one number between 1 and 10 has to be selected. Suppose 5 is selected. Then the first sample will be 5th. And then we have to skip by 10. Then the next one will be 15, then 25th, then 35th, and so on. So one of the advantage of this method is that it is more convenient than other methods and simple to design. That not every time you have to draw, only one time you have to draw. First one is 5th, then every will be 10th individual will automatically will be get selected. Okay, again it is used with very large population. Say for example, we are having a very large population, not 600, we have 6 lakh, then we cannot make this 6 lakh slips and then do this thing every day. Okay, so we go for this systematic random sampling using the skip interval. Okay, now comes your stratified random sampling. How this stratified random sampling is done? In stratified random sampling, the target population of n units is first divided into k subpopulations. Okay, what they do? Say for example, there are n units, so they will divide those this population into k subpopulation, such that each group will be having n1, n2, nk units. Okay, now these population are non-overlapping. That is, the number of individual in this n1 are not being included in n2. These are mutually exclusive from each other. Okay, so together all of them, if I add all these numbers, it will equal to n. Now, if the total sample size n is to be drawn from the target population, then from each subpopulation we are going to select the individuals. That is, n1 from capital N1, then n2 from capital N2, and then similarly nk from capital NK. And sum of these drawn samples will be equal to the total sample required. Now, if a simple random sample is drawn in each stratum, The whole procedure is described as stratified random sampling. So stratified random sampling requires more than making the list of elements and estimating the number of elements in the list. It also involves ordering that list by subgroups or strata and then do the sampling randomly or systematically within those subgroups. Okay, so this method of sampling is used because of the following. Why we use this? It can reduce the errors in statistical estimate calculated from the sample. Because you have made subpopulation. So the samples are going to be come from each strata of the population. So the representation of the population is proper. Second thing, it allows you to create a sample. This is sample. Sample that is exactly representative of various subgroups in the population that you find to be of special interest. Say, for example, the selected village may have households which are of SC, ST, OBCs, and other minorities. Okay. Now, the village population first may be divided into smaller subgroups of different sections of the population stratum, and thus the village sample may consist of households from each stratum, so that the sample may contain all important characteristics of the village population. So in the case of simple random sampling, the sample of all strata subgroup sometimes may not be included or covered adequately. Say for example, in this village, if you are doing simple random sampling, it may be possible that very few individuals from this others category might come. Okay, but if you do the stratified random sampling, they from every stratum you are going to get the your sample. Okay, so this what are the advantages? So this method helps in conducting and managing a large scale survey to be conducted in a country like India, because we are very diverse. Okay, so from each side, from each stratum, we need to have the sample. So the agency conducting the survey may have field offices in different locations. Each one can supervise and survey for a part of the population. Now, the basic idea is that it subdivides the heterogeneous population into homogeneous subpopulation. Okay, small homogeneous subpopulation. In each stratum is homogeneous in itself. A precise estimate of any stratum mean can be obtained from small sample, thus saving lot of time and cost. Okay, so even if we are going with the stratified random sampling, even with a small sample, you can estimate and inference the various statistics we have. Okay, so there are two type of stratified samples. Okay, one is the proportionate stratified sample, right? So what is a proportionate stratified sample? A proportionate stratified sample selects the number of elements from each stratum so that the stratum sample size, this is size, say for example N1, N2, Np is proportional to their respective stratum populations. Say for example, if more SC are there in the village population, then the sample you are taking from the these SC people will be more. Okay, so it is proportional, right? Is proportional to their respective stratum population size. So now, say for example, you consider this examples. If a selected village may have households of SC 10%, ST 5%, OBC 45%, other 30, and minority 10. So a village sample of 100 may constitute the household of various castes in the above proportion percent, so that the sample may contain all the important characteristics of the village population. Okay, these all together constitute 100. Okay, 100%. So, if we are going to take the 100 individuals from these 1000, say for example, there are 1000 individuals in this village. So, 100 will be SC, 50 will be ST, and this 450 will be OBCs, 300 will be others, and 100 will be minority. So the sample drawn out of those 1000, if we draw 100 sample, then if this sample, it has to be out of these 100 SCs, you have to select 10 SCs. Okay. Then out of 50 STs, you have to select 5 STs. Then out of 450 OBCs, you have to select 45 OBCs. Then out of 300 others, you have to select 30 others. And then out of 100 minorities, you have to select 10 minorities. Like this. Okay. Now, also, sometimes these hospital patients are stratified according to age, dividing the population into those who are aged 50 years or above and those who are under 50. If there are twice as many people aged 50 or above admitted to the hospital as those under 50, a proportionate stratified sample will include twice as many people aged 50 or above. So, accordingly, in a stratified, proportionate stratified sample, the sample size from each stratum is proportional to its value. Okay. Now, what is disproportionate stratified sample? Okay. So, disproportionate stratified sample selects the number of elements from each stratum so that stratum sample size is not proportional to the stratum population size. The most common reason for selecting this type of sample is when you want to study a relatively rare but important subpopulation, such as younger patients suffering from heart diseases, be very few. And if you will be studying the proportionate stratified, you will be getting a very less sample for those particular type of subpopulation. Okay. So accordingly, a disproportionate stratified sample is used. So proportionate stratification may result in too few elements being selected so that little, if any, statistical analysis can be done. Consequently, if even if these patients represent only 1% of the population, you may decide to make them 10% of the final sample so that you will get some insights about the data. However, once we combine values of all stratum, the size of higher selected population need to be readjusted, which is done by using the weighted estimates. Okay, so that is beyond the scope of your this syllabus. So this is the disproportionate stratified sample. Now, what next type of sampling is probability proportion to size sample. Okay, so it has been observed that elementary units of population vary in size. So such ancillary information about the size in the unit can be utilized in selecting the sample so as to get better and efficient estimate of the population parameter. For example, villages with large geographical area are likely to have larger areas under food crops. Therefore, in estimating the production, it would be desirable to adopt a sampling scheme in which villages are selected with probability proportional to geographical. Okay, so when units vary in their size and the variable under study is directly related with the size of the unit, okay, then this probability is proportional to size sampling is done. So the probabilities may be assigned proportional to size of the unit. So probability proportional to size sampling assures higher probability of selection to sampling units which are larger in size. So this technique was initially used to estimate the crop production or even milk production or food production, any type of productions, okay, etc. Because productivity is directly related to the size of the field. So in social science, surveys also characterize characteristics of the village population are influenced by the size of the population. So the procedure of selecting the sample is described below. So suppose you have to select 5 villages from the list of 10 using PPS sampling. Okay. So first arrange all villages in ascending or descending order of the population size as may be seen in the column 2. Okay, of the table 1. Then in the third column find the cumulative sum of the population size, and in the fourth column assign then a range of serial number as shown in the table. Okay, so what we do, say for example we have the population size of 10 villages like this, so we have arranged them in ascending order. Okay, now we will find out the cumulative frequency. This is 200, then this will become 450, this will be 750, like this. These are cumulative frequency. Then we will provide them the size interval, that is 1 to 200, then 200 to 450, then 450 to 750, like 3600 to 4250. Okay. Now, notice that the total population of all villages in the target population is a 4-digit number, 4250. Therefore, initially a random number in 4-digit visit which is less than or equal to the total population of all villages 4250 is selected from the random number table. Also depends on the random. So, for example, if it is 0331, which will correspond to a serial number 2, first random number came out to be 0331. So, where it will reside? It will reside here. So, village number 2 will be set. Okay, which correspond to number 2. Next random number is 4320. Okay, therefore, it may be discarded because we have at most 4250. Then the next number selected is 1296. Then it will correspond to 1296 where it will be 1296. So it will be here. So it will be in the fifth village. Okay, number 5. The next number may be 1153 2402 360 3640, which will correspond to serial number 6810 respectively. In this way, the selected villages will be serial number 2, 5, 6, 8 and 10. So this is how we do the this one. Okay. Now your in this probability sampling is your next one is cluster sampling. Okay. Then there will be known probability sampling. So in this class we will do up to cluster sample, and then from the next class we will be starting from the known probability. So what is a cluster sampling? So cluster sampling is a sampling technique used when natural groupings are evident in the statistical population, and there are natural grouping are already available there. So it is often used in marketing research. In this technique, the total population is divided into these known groups or clusters, and a sample of group is selected. Then the required information is collected from the elements within each selected group. Okay. So this may be done for every element in these groups, or a sub-sample of the elements may be selected within each group. So the technique works best when most of the variation in the population is within the group, not between the groups. Okay. This is very important, that the variation works best when the variation in the population is within the group, not between them. Okay, between group variation is very less, within group variation is high. So, briefly, the procedure for selecting a cluster is given below. Okay. There was a problem in the net. Okay, now it has connected. So the cluster sample should be used only when it is and it is economically justified. Then reduced cost can be used to overcome the losses in the pre-season, and this most likely occur in the following season. When it occurs, constructing a complete list of population element is difficult, costly, or impossible. So then we go for the cluster sample. For example, it may not be possible to list all elementary units of the population. For example, all households in a village, block, etc. Okay. However, once you select certain villages, then within village or within block, you can do the sample. So then this cluster sampling is used. In this case, each village or either a block is considered as a cluster. We have 10 villages. Out of that, we select 2, 3, 5. Okay. So in those villages only we will be studying. Okay. Then the population is concentrated in natural clusters like city blocks, schools, hospitals, etc. For example, to construct personal interviews of operating room nurses, it may make sense to randomly select a sample of hospitals first, okay, and then interview all of the operating room nurses at that hospital using cluster sample. The interviewer could conduct many interviews in a single day at a single hospital rather than in simple random sampling. In contrast, might have to interviewer have to spend all the day traveling to conduct a single interview at a single hospital, because some of the individual will be from this hospital, some will be from other, some will be from other. So when a natural boundary is there or natural classification is there, so we sometimes go for this cluster sampling. Okay. So, as discussed above in the cluster sampling method, the primary selecting unit is not a household, rather a natural cluster of households. Okay. This can be hamlets in villages, or it can be created clusters like schools, malls, etc. So the first list of cluster may be selected using simple random sampling or probability proportionate sampling methods, which have already been described. Then from each selected cluster, all the units or some of the units may be selected as per the required sample size using stratified random sampling or systematic random sampling techniques. Okay, so the sampling technique, this sampling technique, cluster sampling, is quite popular in evaluation of the survey in health. Okay, and it is also called the 30 cluster sampling technique. Okay, this is also a rapid method of data collection, as the researcher can collect more data in less time due to decrease in the transportation time as compared to other sampling techniques. So this completes your probability sampling. Okay, then in the next class we will be starting with the known probability sampling method. Okay, so as there were no questions there, so this is all from today, and thanks for your patience hearing. Okay, so your attendance will start at 1:45. You can mark after that. Okay, as usual, which has already been sent on your mail, and we will not be having class from 2 to 3. Okay, thank you.